Good morning, guys. Can you hear me?
Yes, Miss.
Okay. How many were you in the first session? How many were
We
you?
were 13, yeah, Miss.
You were 13? All right. So let's take the attendance. Ali is not here. Aisha?
Here.
Farida? She's not here. Hannah?
Yes.
Hala?
Yes.
Haya?
Yes.
Khulud? Khulud is entering. Okay. Limar?
Here.
And Najat is entering too. Okay. Limar is here. Malak?
Here.
Okay. Mariam?
Yes.
Muhammad Ahmed, of course, is not here. Mustafa is not here. Najat?
Yes.
Khulud, are you there?
Yes, I'm here.
Okay. Noor Tamer is not here. Ruqayya?
Here.
Yasin Abdel Hamid? Not here. Yasin Tamer not here. Who is here? Yeah, Yasin Abdel Hamid is here. Okay. And Yasin Radwan?
Here.
Okay. So let's first start with some questions. If you know the answer, please raise your hand. First of all, I'm going to ask you about the acids. I want to know the tartaric acid, what origin is it and where can we find it? The tartaric acid, what origin is it and what origin is it, whether it's plant or animal, and where can we find it? What origin is it and where can we find it? Okay, Yasin Muhammad Radwan.
It's a plant.
It's a plant origin, and where can we find
Plant
it?
origin in grapes.
Grapes. Thank you so much. Thank you so much. Okay, very good. The next one is the lactic acid. Lactic acid. What is its origin and where can we find it? Lactic acid. What is its origin and where can we find it? Yes, Limar.
The origin is animals, and we find the lactic acid during muscles in vigorous exercise.
Yes, so we find it in the muscles during vigorous exercise. Thank you, Limar. Very good. Okay. What is the chemical name of vitamin C? What is the chemical name of vitamin C? What is the chemical name of vitamin C? The chemical name, people started to lower their hands. What is the chemical name of vitamin C? Yes, Hannah.
Absorbic acid.
Not absorbic, guys, because this is the second time I hear this. What's the meaning of absorbic acid?
Ascorbic.
Yes, ascorbic acid. Ascorbic acid. Absorbic means that you're absorbing something. Ascorbic acid. Okay, and what is its origin, Hannah?
Found in plants,
Plants,
and
where exactly?
citrus fruits, and berries.
And black currants, yes. Thank you, Hannah. Okay. What about the uric acid? What about the uric acid? Its origin and where can we find it? Its origin and where can we find it? Yasin Abdel Hamid.
Animals,
Origin?
animals,
Yes.
and it's found in urine.
And it's found in urine. Very good. Okay. What is the name of the acid that is found in mammalian stomach? What is the name of the acid that is found in mammalian stomach? The name of the acid that is found in mammalian stomach. What about the rest of the people? Of course, I thank you so much for the people who are raising their hands. Thank you so much for your care. What about the rest? Anyway, Mariam, yes, Mariam. What is the name of the acid that is found in mammalian stomach?
Hydrochloric acid.
Thank you so much, Mariam. Excellent. Hydrochloric acid. Hydrochloric acid. Okay. Now, there is an acid that has both origins, plants and animal. What is the name of this acid? You can find it in plants and you can find it in animals. What is the name of this acid? Yes, Aisha.
Methanoic acid.
Methanoic acid. Yes, methanoic acid. And where can we find it in plants?
In the nettle stings.
Yes, and what about the animals?
And sting.
And sting. Thank you so much, Aisha. Okay, so that was everything about the acids. Now, the next question is true or false? True or false? Dilution means the process of decreasing the amount of acid. Dilution is the decreasing of the amount of acid. Yes, Hala.
False.
False. It's the decreasing of what?
Of the amount dissolved.
No, it's the decrease of what, Hala? It's not the decrease of amount. It's the decrease of what? Concentration. Concentration. It is the decrease of concentration. Okay, it's not the decrease of amount, it's the decrease of concentration. Okay, next question. Diluted acids are corrosive, true or false? Diluted acids are corrosive. Ruqayya. Diluted acids are corrosive.
True.
Oh yeah?
No. It's false.
Of course, because if it's not true, it will be false.
Can I say what it is?
Hannah, what is the corrosive acids?
Irritant.
Yes, the diluted acids are irritants. What about which one is the corrosive acids? The corrosive acids are what? The opposite of diluted.
Concentrated.
Concentrated, yes. Concentrated acids are corrosive, while diluted acids are irritants. Again, concentrated acids are corrosive, while diluted acids are irritants. Okay. Now, let's move to the alkalis. The alkalis. What is the name? Give me an example of an alkali which we use the concentrated form of it in the laboratories. A name of an alkali which we use its concentrated form in laboratories. The name of the alkali that we use its concentrated form in laboratories. Yes, Limar.
Potassium hydroxide.
Potassium hydroxide or
sodium hydroxide.
Thank you, Limar. Sodium hydroxide or potassium hydroxide. Thank you so much. Okay, give me what do we use the concentrated form of calcium hydroxide in? What do we use the concentrated form of calcium hydroxide in? We have two forms of calcium hydroxide. One is the weak solution and the other one is the concentrated form. I want to know the use of the concentrated form. Yasin Abdel Hamid.
Used in industries to make bleach.
To make bleach and whitewash. Thank you, Yasin. I want someone to tell me the other name of the concentrated calcium hydroxide. The other name of the concentrated calcium hydroxide. The concentrated, not the weak solution. The concentrated, not the weak solution. What is the other name of the concentrated calcium hydroxide? Yes, Mariam.
Lime.
Excuse me, I couldn't hear you.
Lime.
Lime, very good. Thank you, Mary. Okay, what about the weak solution of calcium hydroxide? We call it lime water. What is its use? What is its use? The weak solution of calcium hydroxide. What is its use? Yes, Hala.
We use it to test the carbon in our breath.
Carbon what?
Carbon dioxide.
Carbon dioxide. Carbon dioxide. Okay. Yes, we use it to test the carbon dioxide in breath. Okay. I'm looking for the other questions. Yes, give reason. After a while, wine will have a sour taste. Give reason. After a while, wine will have a sour taste. Come on, guys. Give reason. After a while, wine will have a sour taste. Only Limar knows the answer. After a while, wine will have a sour taste. Okay, say it, Limar, since no one knows.
Ethanol plus oxygen equals sour.
Equals sour? Is that a product?
No, sorry.
Equals what or gives us what? It's not equals. It gives us what?
It gives us vinegar, I think.
Yes, dear. What is its chemical name? You said ethanol plus oxygen. It will give us what? What is the acid that is found in vinegar?
I forgot its name.
What can I say?
It's similar to ethanol. And we have something that, a name that looks like it, which is in the ant sting. It looks like it.
Ethanoic acid.
Ethanoic acid, thank you so much. So ethanol plus oxygen gives ethanoic acid. And what does that mean? It means that the main component of the wine is the ethanol. This is the alcohol found in the wine. And we have some dissolved oxygen also in the wine. After a while, they will react together and they will produce the ethanoic acid, which is the component that makes the vinegar. Okay. Okay, let's now move on with the lesson. And every session will be starting with these questions, okay? So, of course, I wrote the names of the people who participated with me and the ones who were raising their hands, and the rest, pay attention, okay? I will give you another chance. Next time, I want everyone to be raising their hands, or there will be deducted marks. Okay, so where did we stop? Yes, we stopped right here. Yesterday, I just need to plug my laptop because it's going to turn off. Okay, guys, I'm back. Okay, so yesterday we were talking, until yesterday, we were taking this general information about acids and alkalis and about their examples and about their origins and how they were divided from the first from the ancient centuries, and we knew everything about their names and how they formed those names. And let me just ask you one more questions, guys. What is the origin of the acid name and what is the origin of the alkali name? Before I move on, what is the origin of the acid name and what is the origin of the alkali name? Yes, Yasin? Yasin Radwan.
Acids, acidus,
Yes, and this is what is its origin? Is it Arabic?
Greek
Is it
name?
No, it's Latin.
Latin, sorry.
Latin, yes,
Yes,
okay. What about the alkali?
And Arabic name, Al-Qalawi.
Yes, thank you so much, Yasin. Okay, so those are the origins of their names. Now, we have the acids and the alkalis in our lives. And of course, it doesn't make sense that in order to know which one is which, I want to differentiate between them. I have a bottle of a chemical, and I know that it might be acid or it might be an alkali. It doesn't make sense that I open the bottle and drink some of it to see whether it tastes sour, or maybe I will pour or spill some of it on my hands to see whether it's slippery or not. That doesn't make sense because we said that there are concentrated forms of both of them which are corrosive. So we are going to die if we did so. So we cannot just take a sip of the chemical or put it on our hands to see whether it's sour or whether it is slippery. Okay, so throughout centuries, throughout the years, a lot of scientists came out with a lot of ways to detect or find out the difference between acids and alkalis. And this is what we're going to learn about right now. First, there was this scientist, which is called Robert Boyle, and he was an Irish scientist. And he was looking or searching for a way that he can easily identify or know the difference between acids and alkalis. He knew that the workers in France, they use the plant juices to dye the silk clothes. What does that mean? It means that in France, they had those cotton garments, they have cotton clothes or fabrics, but they were all white. They wanted to give the fabric a color. How were they dyeing or how were they coloring those fabrics? They were using the juices of some plants. So they brought the juices of some plants, like for example, some people use the bait, which is a type of plant which has a very strong red color. Some people used cabbages, which gives also this faint red color. Some people were using blueberries and stuff, different fruits to give color to the fabric that they are going to put on. So he started, when he remembered this or he knew this information, he started to test those juices and see how will the fruit juices react with acids and alkalis. Maybe one of them will be able to change the color of the fruit juice. This way, he can find a solution for his problem. He wants to detect or find out the difference between acids and alkalis. So what is he going to do? He's going to use the juices of the fruits to see how will the acids and alkalis react with them. Is it clear, guys? We're going to talk still about it. But do you understand so far?
Yes.
The concept, yes, that he used. Okay. Now, what he used was the red cabbage juice. He brought this red cabbage, the one that we do the coleslaw with. And he used its juice to see how will the acid and alkalis react to it. So what is the color of the red cabbage juice? The main color or the original color of the red cabbage juice is purple. He found out that when he adds acid to it, the juice will turn red. And when he puts alkali to it, the juice will turn green. See how smart he is? He used a previous information that he knew, something that is not related even to acids and alkalis, to test or know the difference between acids and alkalis. So he brought the red cabbage juice, which is originally purple. When he added acid to it, he finds that it's turning red. And when he used the alkali, when he added the alkali to the purple red cabbage juice, it turned green. This helped him to identify or find the difference between the two chemicals. Okay? Did this session end? Should I start the new one? It ends when?
We'll have 7 minutes.
It ends 9:20, then we have snack. We will start again 9:30.
Okay, so it ends 9:20. Okay, just please remind me, because the idea that the session is only 35 minutes. What? Yeah, okay. Just tell me, because the idea that you have only 35 minutes in the session, it just confuses me a little bit.
Okay.
Okay. So after Robert Boyle tried this way, other scientists came and they started to use or go on this way. They wanted to find out whether there are other materials or other things that we can use to know the differences between the acids and the alkalis. They didn't have enough when they found out about the cabbage juice. They wanted to test other materials. Now, all of the materials that were discovered later on, whether it was the cabbage juice or after that, we will know that things got really advanced and people are using different materials now. All of those materials that we use to differentiate or find out the difference between acids and alkalis, they called them indicators, because they indicate whether this chemical is an acid or an alkali. Okay, so the thing is that any chemical that was used during all of the previous years and during the present time, all of the materials used to detect the acids and alkalis, they call them indicators. And they were depending mainly on the change of color. It did not depend on, for example, if I added acid, a gas will evolve. So this is how I will know that this is an acid. Or if I added an alkali, something will explode, for example, and this is how I will know it's an alkali. No, all of the trials were about chemicals that change its color when acids or alkalis are added to them. And this is why they call them an indicator. So the indicator is a dye. A dye means a color that changes its color depending on whether the solution is acidic or alkaline. Okay? Many plants contains those indicators. So up till now, some of the indicators are plant-based. They are brought or they are discovered from plants, and they change their color once they react with acids or alkalis. Okay, is it clear so far, guys?
Yes.
Okay, I just want to tell you that in the next session, it's going to get really interesting, and not today's session, next week's session, because I will be bringing some of the materials or the indicators, and I will try with you on the Zoom, and I will show you how they change their color. Okay. So,
Miss, how is it going to be interesting? And this lesson is not interesting. This lesson is so hard.
it's not hard at all. You just have this mindset that it is hard because you're still babies. You need to grow up. Once you grow up, you will be just fine. Okay? So, all right. The session has ended.
No, 3 minutes left.
We still have
3 minutes left.
We have 3 minutes. Okay. All right, guys. So as I told you, many plants contain dyes that can be used as indicators. Okay. Now there is something called litmus, and litmus is actually one of the materials that contains a plant dye. It is called litmus paper, and we still use it till this moment. Litmus paper is a paper, just small pieces of paper, and you will find their pictures in page 10, and I will show it to you right now on the screen. Of course, there is a major mistake that has been done in pages 9, 10, and 11 and 13, that the book was printed in black and white. So you cannot actually see the difference or the different colors of the plant juice or the litmus paper or some of the indicators that we will talk about later. So the litmus paper is the one found in page 10. They are like very small strips of, this is the litmus paper. Small strips of paper that we added some plant dye on it, plant color on it. And it has two main colors. Some of them
Miss-
are, yes,
Miss Nisma,
yes.
can you please repeat what you said because you lagged for a minute?
Okay.
What's wrong with
I will
page-
tell you something. I will end the session and we will continue after 10 minutes. Okay. Do you have 10 minutes?
Yes.
It's only 1 minute left.
Yes, the snack time, is it
The
10
snack,
minutes?
oh yes, it's 10 minutes.
Okay, I will end it now. I will end it
Okay,
now
bye.
and I will be seeing you after 10 minutes. Bye-bye.